So once you get those numbers, you're going to take that slope, and I'm going to round it 51.3. That's your slope. And your B value was 143.9. The slope of the line is y over x. Y over x. And that's going to be 51.3 over 1. That means for every foot that you gain in height, you're going to go up by 53 pounds. So 1 foot in height is a gain of 51.3 pounds. The y-intercept is negative 143.9. Now there are two things that you need to understand. First, that it indicates that if you were 0 feet tall, you would weigh negative 143.9. But a second thing that it indicates, and I think more importantly, it's not realistic towards the extremes of the estimation. As you go down lower, you can't lose 51 pounds per foot. You'll notice at 5 feet tall, you're a little bit over 100 pounds. That means if you were under 3, 50 times 2 is 100 pounds. If you're under 3 feet tall, you're going to be pushing like 10 pounds. It's not entirely realistic of an expectation. But this would indicate if you were 0 feet tall, you weigh negative 143.9 pounds according to the line. Doesn't make a lot of sense. Corresponding height if you weigh 120 pounds. So 120 pounds is our y. I've got an m value of 53.1. X, my height, is unknown. And then my b value is 143.9 rounded. So I'm going to take and I'm going to add that to the other side. I've got 120 plus 143.9. I'm going to take and divide off my 51.3. And that'll give me 5.14. Now you'll notice this is feet. If I go into my graph and go to 5.14 feet, it's right about where 120 pounds would hit on that graph. So this is a solid estimation according to that line. Moving along, next page. I've got marriage licenses. They're going down each year. We want the slope. We want to approximate that line. The first thing I need to do, go in, press the stab button, which is right here again, and edit my list. Now what I'm going to do here, I'm going to call this year 1, year 2, I can't write sideways, year 6, year 8. This is years since 2000. So that would be year 1, year 2, year 6, year 8, year 12, and year 14. Over here in L2, number of marriage licenses, and I'm going to leave them in the thousands so that so that I can be a little bit more accurate. I don't want to leave off a 0 and get the problem wrong. And then 93,000. Same thing, I want the linear regression equation. So statistics, we want to calculate the linear regression equation, calculate that linear regression equation. It's going to give me my, remember, y equals ax plus b, that a is your m. So my slope is negative, and this is in thousands, so I'm going to switch it back over to thousands, 3,744. That's marriage licenses per year that we're losing. And then my b value, my intercept, is 146,167. And this is year 0. Year 0. Remember, x, y at the y-intercept, x is 0. Our x value is years since 2000. The slope, we're losing 3,744 marriage licenses per year. The y-intercept means we had 146,000 marriage licenses in the year 2000. According to the model, in what year did Clark County issue 130,000 marriage licenses? So that's my y value. I'm going to set that equal to mx plus b. And we will do some quick math here. 130,000. We're going to minus off 146,000, 167, and then we're going to divide by negative 3,744. It's going to take 4.3 years from the year 2000. So it's going to be like, March or April of 2004. If you look at 2004, you'll notice, boom, right there. So it's a solid approximation according to the data. Next one. On this one, will they get past the first game? Depending on your rank, it's going to change your probability. We're going to go in. We have a new list, so we're going to edit our lists. Rank 2, rank 4, 5, 6, 9, and 10. 89% chance here. 80% chance here. 77, 68, 44, 77, 44, and 40. Double check, make sure all our lines line up, and we're ready to go. I want this linear regression. Keep pressing the wrong button. So I press the stat button. We're going to go over to calculate that linear regression. And we've got our right L's. L1 is our X value. That's what I put in. L2 is our Y value. That's what I put in. Calculate that value. So I've got negative 6.5 and 105.6. That's my M value. This is my B value. Let's talk about it. Now, this is our probability, and this is our rank. What's the slope of the line represent? For every rank you drop, your probability drops by 6.5%. So, if you're rank 5 versus rank 6 has a 6.5% less of a chance to go on to that second, according to the data. The y-intercept, if you were ranked 0, you have a 105% chance of moving on. Fantastic. But again, you can't be ranked 0. You'd be ranked 1. And ranked 1, you'd have a 99-point-something% chance. So again, just like the other one, it's not a realistic data point. Not a real data point for rank 0. Based on this model, a school with a 86% chance of winning their first game would have what rank? Here we go. 86 is our percent chance. We know that our slope is negative 6.5 attached to X and plus 105.6 for our y-intercept. Now we're going to estimate that it's going to be 3 or 2 somewhere in there, but just for fun, we're going to pop this out. We're going to take 86, we're going to subtract the 105.6 to the other side. We're going to divide that by 6.5, and it's going to be negative 6.5. There we go, rank 3. And if you look, rank 3, boom, right up there, 86-ish, not bad, not bad. There you go. Next problem. Determine what type of situation the slope would have. The heat of the oven when you turn it on. It's going to go up. We're going to say positive. The excitement for a team as they start losing more games. Excitement goes down when you start losing. Negative. An athlete running consistent times for 40-yard dashes. 0. Positive slope situation. Filling a pool. And height of water. As you fill that pool up, the height gets taller, so it's going up. Negative situation, ball falling. We'll say ball rolling down a hill. Again, this would be the height of the ball. Slope of 0. So the height of a car on a flat road. Car is always going to be at the same height, no matter how far it goes on that flat road. We'll cut the video here. Do one more.